Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be looking at another question number 3. It's another suggested question for question 1 from the coverage of a grade 11 elite for this term 2. So we have this piecewise function R of t. Says the total accumulated revenue a company has received up to time t is modeled by the function R defined above, where R of t is measured in millions of United States dollars and t is the time in years since 1980. Part A, find the limit of R of t as t approaches infinity. Explain the meaning in the context of this problem. So, let's get started. For part A, we need to find the limit of R of t as t approaches infinity. And this is a piecewise function. We know that infinity is satisfying this inequality. So infinity is here, so we'll use this this subfunction, the second one. So it's equal to the limit as t approaches infinity of 100 t squared plus 1000 over t squared plus 600. Okay, so the degree on the numerator, the highest degree is 2, and in the denominator it's 2 as well, and the ratio of the coefficient will be 100 over 1, so the answer for this will be 100. So what does that mean? The limit as t approaches infinity equals 100, and R is measured in what? R is measured in millions. So we can just say that as time increases, the total what? R refers to revenue, right? The total revenue, right? So the total revenue the company has received, or the total revenue approaches 100 what? 100 millions. So this is the first part. Now, let's look at part B. Part B says, is the function R continuous at t equals 20? And you can see that 20 is here and it's here, so we need to check both sided limits, because it's likely to have, like, let's say, a jump or discontinuity, but we will see. So let's first find the limit of R of t as t approaches 20 from the left, the limit of R of t as t approaches 20 from the right, and R of 20. So this is the limit. This is the limit as t approaches 20 from the left, as t approaches 20 from the right, of what? Which piece is used for the left-sided limits? It's the first one, right? So 41 square root of t over 20, and the second one is 100 t squared plus 1000 all over t squared plus 600. And for R of 20, the equal is with the second piece, so this is going to be 100 times 20 squared plus 1000 all over 20 squared plus 600. So let's find out what each of these limit equals to. So if you plug in the 20 in the first one, you will get 41, and substituting 20 in the second limit, which is the right-sided limit, it gives 41 as well. So left-sided equals right-sided equals the function value. Because the three of them are the same, right? So we say that the limit of r of t as t approaches 20 equals r of 20. Okay, limit as t approaches 20, it includes left and right. So this is 20, right? So we say that yes, r of t is continuous at t equals what? At t equals 20. So you have to check the three of them. So for part C, it says the total or the company's total accumulated expenses up to time t is modeled by the function e. So the question is introducing another function, which is e of t. It represents the expenses, the total accumulated expenses. It's measured in millions as well. According to these models, is there a time t from 0 to 5 at which the total profit r of t minus e of t is equal to 0? So we need to find what? We need to find, we need to apply the intermediate value theorem here. So, first of all, we need to mention that r of t, which is the given function on top, and e of t are both continuous, check the spelling, continuous on the interval, what interval? From 0 to 5. Why did we choose from 0 to 5? It's mentioned in the question here, right? So if they are both continuous, we can apply the intermediate value theorem, right? So let's find the profit at t equals 0, which the profit is given by this difference, right? So here r of 0 minus e of 0 is equal to r of 0. We found it, I think, before, but we can just use it here. So it's 41 square root of 0 over 20. This is r of 0 minus e of 0 is given in the question. You just need to copy the function e and just replace the t with 0 and use your calculator to evaluate. You are going to get -6. You are going to get -6. And do it again for r of what? R of 5 minus e of 5. So 5 lies here in this interval. Okay. So we will write 41, right? So 41 square root of 5 over 20 minus, again, copy the function e given by the question, but replacing t with, replacing t with 5 plus 4 and evaluate, you should get 2.5. So we found the profit at t equals 0. We found the profit at t equals 5. 1 minute. So we found the profit at t equals 0. We found the profit at t equals 5. The question says, in part C, it says, is there a time t in this interval at which the profit equals to 0? So I would like to organize what we have done in a small table where we have here we have what? T, and here we have R of t minus E of t, which is the profit. And this is R of t minus E of t. Okay? And this is t. So when t equals 0, the profit was -6, right? There was no profit actually. And after 5 years, at t equals 5, the profit is 2.5 million, right? 2.5 million. Now, it says, is there a time t at which the profit was 0, or the profit is 0? Well, 0. So 0, it can be between the -6 and 2.5. So yes, there can be a t value between 0 and 5. So what do we say? We can say yes by the intermediate value theorem, IVT, intermediate value theorem. Please refer to the intermediate value theorem in this question. Okay, according to the intermediate value theorem, okay, and we mentioned on top that R and E are both continuous. You need to mention, this is important, okay? You need to mention. So there must be, right, there must be at least, and in the class we explained why do we say at least here, right? There must be at least one time t, okay, for the interval from 0 to 5, such that the profit, which is R of t minus E of t, equals 0. So if you are writing this, you are going to get the full credit, but mention the intermediate value theorem and mention that R of t and E of t are both continuous on the given interval. So now let me look at the answer key for this question. Part A has 2 points, finding the limit as t approaches infinity and the meaning in the context of the problem, 2 points. Part B is 3 points for the limit from the left, limit from the right, and the answer with justification. That means saying that R is continuous at t equals 20, sorry. And part C is 2 points also. So 1 point is for referring to the intermediate value theorem, and the other point is given for the justification with the calculation we did. Good luck.